Welcome back, guys. We're going to get back into the videos, and we're going to start with a Invergowie video, which is Portal 2 Skies, the last video you saw. I've been away since then, but we're back now, and I'm just going to start getting back into them. So we're going to start with Omega Centauri. Now, I did have quite a nice Omega Centauri from our new block from the other day, but I couldn't quite get rid of a gradient. I might just quickly put it up here on the screen. Like to anyone else's eye, it probably looked pretty nice, but I could just see something down the bottom right hand corner that I wasn't happy with. Now, since finding the color calibration and of Pixinsight and understanding how to work them, my globular cluster images have really come alive. You can see here in the thumbnail, before we get into it, there's lots and lots of color in there. And one of the other factors we did was I actually reduced the exposure from 3-4 second subs down to 1 second. So we weren't saturating each pixel, each star. So the more you saturate them with a longer exposure, and then it's a lot harder. They just turn all white and you can't get that color back. So yeah, so I've actually lowered the exposure down to 1 second for this one. I did do about 20 minutes, which was in line with what I said. We were going from 5 minute captures and images. And these next ones from Armadale, I've bumped up the total capture time. And I'm pretty happy with some of the results. I've processed most of them, but I'll go back through and we'll do it again. So on this video in particular too, I will actually do my processing on the cluster. And if you're happy with that, you can wait through to the end and you can just watch how I did it. What I'll actually do is I'll probably process it, and then we'll go all the way back to the start, and then I'll just click through next, and it'll show you what I did, and we'll be able to talk through it rather than waiting 32 minutes for each process to take place. So we'll do that. But another thing I'm going to do, and I'll put it up on the screen here now, is Omega Centauri. Now I've got 10-inch, 16-inch and 24-inch Dobs, which you all know, and I would have seen Omega Centauri in each of them at least 50 times. Now what I've done here is I've kept the same image, but I've processed it to what I believe is pretty well spot on what you're going to see on a general night looking through your Dobsonian or your 10-inch scope. And then you can see relative to a 16-inch scope what the change is, 24-inch scope, and so on. Now I've spent a good half an hour processing these, and I think this is pretty close to what the change in each step is, because I haven't been able to take all three scopes out and dump them next to each other on the ground. But don't worry, when you're talking about Omega Centauri, I've seen it a few times. So I believe I've given a true representation of what to expect. Although you can't really get that fineness of seeing it with your own eyes. Like the cameras, their sensors are faulted, basically. Like the camera sensor is just not anywhere near as good as what your eyes are. Anyway, as you'll see, my image is quite a nice image, not too bad, and I really didn't try and blow out. Everyone's seen those Omega Centauri images where the center's blown out. You can't even resolve any stars in the middle. It's just a big white blob, and then you've got the stars around the outside. Well, I really tried to avoid that. So I hope you all enjoy the video and just step through and watch. I don't think I'm going to put the capture footage in there. I might link another one, and because you've all seen Omega Centauri through the scope, so it's just basically yeah, anyway. Okay guys, here we are, Omega Centauri. This is the actual data after it's been stacked. First up, because I use fire capture and just record in 16-bit, it doesn't really have an astronomical solution, so we've got to do the plate solving script. So search for Omega Centauri, there it is, click, click, image solver, yes. And this all ties in with the photometric color calibration. So in order for it to give the correct color for the stars in the image, it must obviously know where that image is, and there's probably about 80 gigs worth of Gaia data that I downloaded, and you put in a folder, and Pixinsight goes back to that. So here we are down here to spectrophotometric color calibration. There we go, I'll spit it out. The sensor is the 571, and those settings there above are just the filters on top of the sensor itself, and then I reference catalogs the Gaia data I have. Alright, it's done that. We'll get rid of that. You can show the stars and their grouping in each sector. Alright, we'll get this out of the road. And I was just about to do a histogram stretch, and then I remembered to go back and do a correction on the stars. This was taken in pretty close to the middle of the night up at Armadale, and it was pretty cold at that time. I did look at it. I didn't know whether I was going to try another collimation on the scope, but it was about -1 or -2 at the time, and I wasn't going to pull my little fingers out. The stars didn't look too bad on the screen. So I've just corrected this. I do have a couple of other images that have come from my imaging with the 24, and I was asked about this on Discord on my old Trifid Nebula image. So I provided this image. As you can see here, it's number 1. It's the first frame of my Trifid Nebula from before. Just don't worry about the artifacts here. This is taken off the screen recorded off my scope. But see the star conditions, all pretty good. And this is an untracked. This is just my normal sub. So I think this was about a 3-second sub, but this is not processed at all. And you can see the conditions of the star. When the collimation's good, the Nexus Coma Corrector is a brilliant piece of gear. So it's really worthwhile for me and my imaging, and it does wonders for what I do with the big Dob. Without it, like I said before, I couldn't do it. I couldn't do what I'm doing. So we're back here. What have we got? Its processing is done, the correction's done, and we're going to go to generalized hyperbolic stretch. Now this is far better than the histogram transformation, because you can control which part of the histogram you're actually stretching by clicking on the image. I'm doing it pretty quick here at the moment, due to the fact that I don't want to make this a 20-minute video. But as you can see, I've just reduced the strength, get a little bit more brightness there. Just do it in little doses, and don't do it all at once, and then you'll get your eye in. So I just have a little bit of a look and see what they're like. Now I think I'm going to, just turn the background, just darken it down. It's starting to come up. So again, take with a grain of salt the screen. This is just a screen recording of, so don't think the image is really like that. It's a bit artifacted. Now protect the highlights. This is just going to stop that central section just blowing out. That's due to the fact that the full well on these scopes when you stretch, full well on the cameras when you stretch them, it starts to blow out the next pixel. Like these, the cameras that we're buying, amazing as they are, that's the limit to them. All the stars you can see, and then when you stretch, that really starts to blow out the core. I did do a an image where I actually used Star Exterminator to pull the stars out of the image, and then you could see the background glow of what was essentially the bleed over from all the pixels when you'd stretched around the stars. And I did reduce that a little bit, and while it was effective, it did look a little bit funky, but I only did it once. So, I mean, maybe that's a factor later on, because if you do a star extraction and then you reduce that halo of bleed over from the background, I mean, you're not modifying, you're just showing more likely what the eye can see. Here we go, just going to add that little bit of colour into the stars that has been put there. And again, not looking to, you know, turn it into a fairy tale or anything like that. Trying to make it look pretty realistic. The images that I showed back in the video about your 10, 16-inch and 24-inch scopes and what they look like through the eyepiece, they're very realistic. This image here is more about just exposing the data that you've captured in the image and trying to show everyone what's really there. I wouldn't say this is completely realistic or anything like that, but definitely those other ones are 100% realistic. This is just about exposing the data that you've captured with the camera. And as you can see, there's no, I'm not going to use any Blur X. I'll use a little bit of noise exterminator later on, but it's just all about trying to bring out. It's too much. We're coming back, and just bringing out the details are there, but there's no, I'm trying to be very minimal with my Blur X stuff. Like the correction of the stars is about the only thing. These ones were a little bit bulky in the corners before I did the correction, but as I said, that was because I was freezing my ass off up in Armidale, and I didn't want to take my gloves off to collimate it after it. I think it probably dropped about 10 degrees, and obviously the collimation shifted a tiny bit there. So just remember, we are still at 2.55, f2.55, which is very, very difficult on the optics. So here we had a look there about the noise exterminator, and that's just the general run that I use, which is 5 iterations and denoise 0.7. Do I know what is the exact mathematical equation being used here? Not really sure, but I do know that around that is more than enough to tidy up this particular image, because Omega Centauri was the last time I did use that. So we're basically looking at exactly the same use case scenario. So, and for my globular clusters, as you can see, very, very minimal different processes we used. What do we got there? 6. I'm pretty sure it's 6 plus the image solver and the color calibration, which is 8 in total for my nebula and other things, which I will do. I still have promised to do a 104 M104 processing. I've been battling the blue screen of death on my PC since I got home. I think it's a motherboard issue, but I've lost a week since we got home from New Zealand, so bear with me, guys. I am going to get more videos out, and hopefully just leave some questions in the comments. Even if you have any questions about planetary imaging or anything like that, questions that you feel that my experience could help you, leave them in the comments and I'll answer them at the end of the next video. I'm happy to do that, and we'll see how that goes. What have we got here? 85%, 88. It's a slow old process, and this is with my images binned. So this is only like a bit over 3,000 pixels by a bit over 2,000 pixels. I did originally do that because I couldn't show you the video, and it wouldn't convert, so I could show you the video and run through DaVinci Resolve. So I binned it, and it turns out to be a better case scenario for me, with the being basically 1 arcsecond per pixel, which is spot on for DSO work. So a little bit more colour. No, what do we got? So I'll do a nice little stretch, a little bit less, see what it looks like. Always moderation, then you can come back, set the point a little bit lower, which will brighten a lot of things. And with that protect the highlight slider at the bottom there pulled across, it's refraining from blowing out the core, which is more about what the eye can see. On the camera, you can blow that core out, and it really doesn't look nice. And also, but when you look through it through your scope at Omega Centauri, it doesn't blow out the core. The core doesn't look like that. Your eye can resolve all these stars, and that's why it's so amazing to look at. And 47 Took is another unbelievable object. So I think I go back a little bit, and I'm going to come back. I think I might, what did I do here? I just processed it. Histogram, give it another little bit of black, darken it off a bit. And there we go. Alright guys, I'm just scrolling back through, and I was just going to repeat the process, but I was able to run you through there. So just let me know any questions in the comments, and we'll come back through, and I'll answer any questions at the end of the next video. So sorry about this long format. I've been busting to get it out, but as I said, I've been having some dramas with the PC and everything. And I'll see you next time. Bye for now.